Hi, before we could continue with our session 4, I just want to go through our activity on session 4, our last session for unit standard 14918. So activity 8 on session 4 is you need to identify methods of specifying problems in designing a computer program. It's for 4 marks. And we will need to identify features of a computer program that could solve a given problem. That's activity 9 and it's for 7 marks. And activity 10, you need to demonstrate an understanding of carrying out an evaluation of the viability of developing computer programs to solve problems and identify the issues in assessing the viability. So those are our activities. We've got 3 activities on session 4. So before we could go through our learning outcomes of session 4, I wanted to go through with you the activities that are in session 4. So let's quickly go to our learner guide to learner guide session 4. Our learning outcomes, you need to description of the methods of specifying problems. You need to identify methods of specifying problems, and then you need to explain the techniques used to research problems in terms of input and output. And you need to do an evaluation of the viability of developing computer programs to solve problems and identify the issues in assessing the viability. And then you need to explain the features of a computer program that could solve a given problem. So methods of specifying problems. We've got a structure chart in software engineering and organizational theory is a chart which shows the breakdown of a system to its lowest manageable levels. They are used in structured programming to arrange program modules into a tree. Each module is represented by a box which contains the module's name. The tree structure visualizes the relationship between modules. A structure chart is a top-down modular design tool. A structure chart is a top-down modular design tool constructed of squares representing the different modules in the system and lines that connect them. The lines represent the connection or ownership between activities and sub-activities as they are used in an organization. Because this is the program structure diagram as it was explained. So the top down and the bottom up are both strategies of information processing and knowledge ordering used in a variety of fields, including software, humanistic, and scientific theories, and management and organization. In practice, they can be seen as a style of thinking and teaching. A top-down approach, also known as a stepwise design or deductive reasoning, and in many cases used as a synonym of analysis or decomposition, is essentially the breaking down of a system to gain insight into its compositional subsystems. In a top-down approach, an overview of the system is formulated, specifying but not detailing any first-level subsystem. Each subsystem is then refined in yet greater detail, sometimes in many additional subsystem levels, until the entire specification is reduced to base elements. A top-down module is often specified with the assistance of black boxes. These make it easier to manipulate. However, black boxes may fail to elucidate elementary mechanisms or be detailed enough to realistically validate the model. Top-down approach starts with the big picture. It breaks down from there into smaller segments. A bottom-up approach, also known as an inductive reasoning, and in many cases used as a synonym of synthesis, is the piecing together of systems to give rise to grander systems, thus making the original system subsystem of the emergent system. Bottom-up processing is a type of information processing based on incoming data from the environment to form a perception. Information enters the eyes in one direction, input, and is then turned into an image by the brain that can be interpreted and reorganized as a perception, which is the output. In a bottom-up approach, the individual base elements of the system are first specified in great detail. These elements are then linked together to form larger subsystems, which then in turn are linked, sometimes in many levels, until a complete top-level system is formed. This strategy often resembles a seed model, whereby the beginnings are small but eventually grow in complexity and completeness. However, organic strategies may result in a tangle of elements and subsystems developed in isolation and subject to local optimization as opposed to meeting a global purpose. So we've got the decision trees, decision tables. First, it takes advantage of the sequential structure of decision tree branches so that the order of checking conditions and executing actions is immediately noticeable. Second, conditions and actions of decision trees are found on some branches but not on other or not on others, which contrast with decision tables in which they are all part of the same table. Those conditions and actions that are critical are connected directly to other conditions and actions, whereas those conditions that do not matter are absent. In other words, it does not have to be symmetrical. Third, compared with decisions tables, decision trees are more readily understood by others in the organization. Consequently, they are more appropriate as a communication tool. Unbalanced decision tables are a compromise between decision tables and decision trees. Decision trees themselves can become more quite complex with enough conditions and actions. Unbalanced decision tables provide either a prioritized list of conditions that lead to a set of actions or a list of conditions that lead to a set of actions. The result is often more concise than either traditional decision tables or decision trees. Let's go to the feature of a computer program that could solve a given problem. So we've got a batch processing is an execution of a series of programs on a computer without manual intervention. Jobs are set up so they can be run to completion without manual intervention. So all the input data are pre-selected through scripts, command line parameters, or job control language. This is in contrast to online or interactive programs which prompt the user for such input. A program takes a set of data files as input, processes the data, and produces a set of output data files. This operating environment is themed as a batch processing because the input data are collected into batches of files and are processed in batches by the program. So the batch processing has these benefits. It can shift the time of job processing to when the computing resources are less busy. It avoids idling the computing resources with minute by minute manual intervention and supervision. By keeping high overall rate of utilization, it amortizes the computer, especially an expensive one. It allows the system to use different priorities for batch and interactive work. This is the batch processing a diagram. You've got a database and the batch program and an input file, and then it outlays the reports in an output file. This is a web server. It's an online transaction processing. So it has layers and online transaction online region, and then within that it has an online transaction program, which is the database. The mouse pointing device sits on your work surface and is moved with your hand. In older mice, a ball on the bottom of the mouse. I guess I think guys, it's what you know. They're trying to explain. You can read this on your own. You can read this on your own just to grasp uh, knowledge about what this two mouse would call the wireless Macintosh mouse. That you can read on your own just to familiarize with that. So let's move further. The techniques are used to research problems in terms of inputs and outputs. An actor in a unified modeling language specify a role played by a user or any other system that interacts with the subject. An actor models a type of a role played by an entity that interacts with the subject, e.g., by exchanging signals and data, but which is external to the object. Actors may represent roles played by human users, external hardware, or other subjects. Note that an actor does not necessarily represent a specific physical entity, but merely a particular facet, i.e., which is the role of some entity that is relevant to the specification of its association use cases. Thus, a single physical instance may play the role of several different actors, and conversely, a given actor may be played by multiple different instances. And UML2 does not permit association between actors. The use of the generalization specification relationship between actors is useful in modeling overlapping behaviors between actors and does not violate this constraint since a generalization relation is not a type of association. Actors interact with the use cases. So we've got the web client and we've got an administrator and an editor and then a customer. So the following are the places where we use the diagrams are used. Requirement analysis and high-level design, model the context of a system, and revise engineering and forward engineering. A sequence diagram is a kind of interaction diagram that shows how processes operate with one another in what order. It is a construct of a message sequence chart. A sequence diagram shows object interactions arranged in time sequence. It depicts the objects and classes involved in the scenario and the sequence of messages exchanged between the objects needed to carry out the functionality of the scenario. Sequence diagrams are typically associated with use case realization in the logical view of the system under development. Sequence diagrams are sometimes called event diagrams, event scenarios, and timing diagrams. A sequence diagram shows as as parallel vertical lines, lifelines, different processes or objects that live simultaneously and and as horizontal arrows. The messages are exchanged between them in the order in which they occur. This allows the specification of simple runtime scenarios in a graphical manner. This is just an example, an illustration of what they are talking about. So we've got another outcome, an evaluation of the viability of developing computer programs. To solve problems, and it identifies the issues in assessing the viability. Mm, Some experts insist that a well-designed program can be written correctly the first time. In fact, they assert that there are mathematical ways to prove that a program is correct. However, the imperfections of the world are still with us, so most programmers are used to the idea that their newly written programs probably have a few errors. This is a bit discouraging at first since programmers tend to be precise, carefully detail-oriented people who take the pride in their work. Still, there are many opportunities to introduce mistakes into programs, and you, just as those who have gone before you, will probably find several of them. Eventually, after coding the program, you must prepare to test it on the computer. This step involves these phases: the disk checking. This phase, similar to a proofreading, is sometimes avoided by the programmer who is looking for a shortcut and is eager to run the program on the computer once it is written. However, with careful disk checking, you may discover several errors and possibly save yourself time in the long run. In the disk checking, you simply sit down and mentally trace or check the logic of the program to attempt to ensure that it is error-free and workable. Many organizations take this phase a step further with a work through a process in which a group of programmers, your peers, review your and offer suggestions in a collegial way. Translating. A translator is a program that, number one, it checks the syntax of your program to make sure the programming language was used correctly, giving you all the syntax error messages, collect diagnostics, and two, it then translates your program into a form of the computer that can understand. And byproduct of the processes is that the translator tells you if you have improperly used the programming language in some way. These these types of mistakes are called the syntax errors. The translator produces the descriptive error messages. For instance, in Fortran, you mistakenly write n2 n is equals to 2 using the asterisk 1 plus j, which has a two closing parentheses. Instead of one, you will get a message that says unmatched parentheses. Different translators may provide different wording for error messages. Programs are most commonly translated by a compiler. A compiler translates your entire program at one time. The translation involves your original program called a source module, which is transformed by a compiler into an object module. Pre-written programs from a system library may be added during the link load phase, which results in a load module. The load module can then be executed by the computer. So we've got the debugging, a term used extensively in the programming. Debugging means detecting, locating, and correcting bugs, mistakes, usually by running the program. These bugs are logic errors such as telling a computer to repeat an operation but not telling it how to stop repeating. In this phase, you run the program using a test data that you devise. You must play the test data carefully to make sure you test every part of the program. So guys, we done with our unit standard 14918. We have completed all our sessions. So I just want to go quickly through I just want to go quickly through the question. Let's quickly go through our activities just to summarize. uh, we've got activity 8 on our session 4, which you need to identify methods of specifying problems in designing a computer program for 4 marks. And you need to activity 9, you need to identify features of a computer program that could solve a given problem, which is 7 marks. And lastly, we've got activity 10, in which you need to demonstrate understanding of carrying out an evaluation of the viability of developing computer programs to solve problems, and you need to identify the issues in assessing the viability. So guys, I hope you will be able, I have trust in you guys. You'll have the ability to complete these activities, and I'll communicate further as to when to prepare yourself for the summative assessment. So we were given 3 days to complete this module, this unit standard. So we managed to complete it on time. So I'm hoping, guys, we can manage to, within 2 days, 2 consecutive days, we could manage to finish this after watching our first 2 videos, session 1 and session 2. You need to complete your you need to complete your activities and further continue further with session 3 and 4. So guys, thank you very much. I hope you are safe, and you are going through your learner manuals. Take care.